Hi guys, this is Mr. Election. SS1 class mathematics. Welcome back once again. Hope you are doing very good. Let's keep staying safe. So coming to our topic, which is on statistics, that we studied quite some time now. The last time we divided it into two, that is the group data and the what group data. We talked about the group data for quite some times, looking at how you can calculate the median and the mean and the mode and the range of what data is given. And I send them in a frequency table. That is, you have three columns for what your item, the tally. You know how to calculate your what get your tally. That is using strokes. If 5 strokes represents what one bundle. After construction, you strike the what the 51, given what number they write out the frequency. So that's that about the group data. And we also look at what group data, which we completed last week on how to calculate the what the mean, the median, the mode, and range, which is also the same thing. That is the subtraction of what smaller number from what higher frequency. That gives you what your range. But we get formulas on how to calculate the what the mean, and after the mean, calculate what how to use assumed mean to calculate your what arithmetic mean. We look at your what the mean, the mode, how to calculate mode, and how to calculate the median. But today we're looking at another ways by which you can what represent data, another way by which you can present data, which is the statistical graph. That is the way by which we use a graphical representation of what information. So I would like to share with you the learning objectives and the notes, and we'll go through it together. Go through the notes together. So this is it. Statistical graph. Statistical graph number one. Learning objective. At the end of the lesson, students should be able to present information or data on the bar chart, pie chart, and histogram. These are one of the three ways by which we use a graph. We'll be looking at bar charts, pie chart, and histogram. I believe you're familiar with bar chart and pie chart and histogram. We'll just look into that together. Number two, plot the cumulative frequency graph. We already know what present a cumulative frequency table. Using your frequency aggregate what cumulative frequency. So the graph derived from the cumulative frequency, or the curve derived from the cumulative frequency, is called what cumulative frequency curve. And another name for it is called OP. So what can you number three is what drawing inference from the what graphs, interpreting how you can what interpret the graph. Introduction. We have discussed organization of data by use of frequency table or cumulative frequency table. Yes. You know your frequency table is and your cumulative frequency table. The characteristic of cumulative frequency table is that the first cumulative frequency table is also equal to what the frequency, while the last digit or the last number of the cumulative frequency is the sum of all the what frequency was considered. We have discovered that the information is better understood from the frequency table than a set of what raw data. Yes, it is better. Informations are better understood when you have what arranged or presented with what data in the what a regular pattern or in the frequency table than when they are what in the raw data. You all know what data are. Our raw data is these are information which are scattered, random. So it is very hard to what to get interpretations from what raw data. So, but when they are presented in the what frequency table, you know what it will be easier to draw what information from it or interpret information what it requires what information. Yes, apart from the frequency table of the frequency table, a clever method of presenting data is what graphical method. A clever method of presenting data is a graphical method, which we'll be looking at in this topic. We are going to bar charts, pie chart, histogram, and what cumulative frequency curve, which is the OD. So the graphical method of presenting data is called mathematics. Is used at the use of what mathematical what diagrams. So these are what we'll be considering in this week's topic. First, look at the bar chart, which you are very familiar with. The parameters of the bar chart is that they are represented what in bars, and each bar must what well spaced, and the space must be equal between what all the what the bars. The space must be equal with what all the bars, but the height of each bar depends on what frequency. Let me take you through the notes. This is one of the most popular types of diagram used to show statistical what information. One of the what statistical graphs we talked about. Bar charts consist of what bars from the name bar charts. So use bar that is or equal with whose height or length are proportional to the quantities or size, that is the height or the length of the what of the bar. Depends on the frequency of the what item considered. Each bar is however separated by equal gaps. They are separated by what equal gaps. That is item 1 and item 2. The distance between them must be the same as what item 2 and item 3. You have to take note of these things very, very well in order to get an accurate chart. You have to take note of these properties very, very well. Example, the table below shows the number of items produced by a company, social enterprise, over a period of what 5 years. Over a period of what 5 years. That is year and what item produced within what for all the years. Let's say in quantities or in kilogram. Let's say 91, they have produced 4,000. 92, they produce 1,500. 93, they produce 3,000. 94, 2005, 95, 5,000. Note your frequency is on what vertical axis, and your what item or variables is always on the what horizontal what axis. This is the vertical axis, is what horizontal or axis. We already know that a graph is represented by what a y-axis and what x-axis, which represents what the vertical and what horizontal. So these are the frequency and what the item produced, that is 5,000, 4,000 in 91, 1,500 in 92, 3,000 in 93, 2,500 in 94, and 5,000 in what 95. So this is your what bar chart. Please get your pencil and your graph and represent the graph and do the graph on what on your own, choosing what a right scale. And you can notice that the gap between the what bars are the same. You have to consider that also. Frequency on the what vertical axis and what variables on the what horizontal what. As you can see from the graph, like I usually say, in 1991 it's what 4,000 quantities were produced. In 92, 1,500 was what produced. In 93, 3,000 was produced. In 94, 2,500 was produced. In 95, 5,000 was produced, whereby the highest was producing year is what is the 1995. So this is how you represent the what the information of the statistical information on the what on a bar chart. So look at the next thing, which is what the pie chart. Another pie chart is different from the bar chart. The bar chart are represented in bars, but pie chart is a what circular what representation of what information in the what sectors. Circular representation of information in what the sectors. That is, the information are divided what into sectors in what in a circle. And you already know the area of the circle is what the sum of angles in the circle rather is what 360 degrees. Why do I represent all this information in what each sector that will accumulate to what 3,360 degrees. So how do you do that? First, you have to what get the total what items considered, the total frequency of the what item considered. Then number two, you find the fraction of what each item to the what total frequency. Then number three, you multiply by what 360 to get what equivalent what angle to represent what sector in the circle. Let me take you through the note. The pie chart is also known as divided what circle. The pie chart is also known as divided circle. The circle is divided into sectors. The angle of each sector is proportional to the frequency of the item that is what represented. That is the angle, that is the sector of each, the size of each sector depends on what frequency of the item. The process is by finding the sum of all the frequencies. First, I told you the first parameter, find the sum of all the frequencies. This sum is used to divide what 360, which is the total degree in this complete what circle. That is to find the fraction of what each item in what in all the frequencies and what multiplied by what 360. Then each of the frequency is used to multiply this result to arrive at what sectorial angle for each item. Each of the frequency is used to multiply this result to arrive at what sectorial angle for each. Like what this means that in order to get the sector, you have to what find the fraction of what of the individual item to the what total what frequency of the items multiplied by what 360 to get your what individual what sectorial angle of the what item. Here is an example. Below is the breakdown of the weekly expenditure of a housewife, what she spends in the week, how she spends her money given to her. Say rice 600, beans 250, provisions 120, meat 230, vegetables 140, transport 260, and garri is what 200. What is in fact the total frequency of this is what 600, 250 plus 250 plus 120 plus 230 plus 140 plus 260 plus 200. I already told you, first thing you do first in pie chart is what calculate what the sum of all the total frequency. Number two, find the fraction of what individual items to the what total frequency. Number three, multiply by what 360 to get the what equivalent angle to be able to represent what in the what circle. One, calculate the total frequency of what items. Number two, find the fraction of what individual items. Number three, calculate what the sectorial what multiply by 360 to get what equivalent what sector. So for rice is what 600. So the total expenditure is what 600 plus 250 plus 120 plus 230 plus 142 plus 260 plus 200 to give what 1,800. For rice, number one is what 600. You already got the what total expenditure, total frequency. So find the fraction of what rice to the what total frequency, which is what 600 divided by what 1,800 times what number three multiplied by 360 to get what equivalent angle. First, find the what total frequency, which is 1,800. Number two, find the fraction of the what individual item to the total frequency, which is what 600 by 1,800. Number three multiplied by what 360, which will give you what 120 degrees. This is applicable to what all the individual items. You can see for beans 250 over 1,800 times 360 equals 50 degrees. That is the equivalent of 250. So the frequency in degrees is what? 50 degrees. Down to the last one, which is what? Gary, 200 was 1,800 times what? 360. When you add all these fractions together, sum them, you have what? 360 degrees. That is 120 plus 50 plus 24 plus 46 plus 28 plus 52 plus 40 to give you what? 360. I'll give you a means just to cross check that. Thank you very much. I believe you have checked the calculation. 120 degree plus 50 plus 46 plus 28 plus 52 plus 40 will give you what? 360. So these are your representatives. You get your what? Get your what? Drawing material, get your compass and your what? Protractor to get the what? Individual angle starting from the what? The center of the circle. You find what? The biggest one first, which is what? Represented what? Right is what? 120 degree. So it takes what? This is the pie chart. Rice takes the what? Largest size. I told you the size of each circle depends on the what? On the frequency. As you can see from the what? Table, 600 is what? For rice, and it's what? Largest what? Frequency there. So it takes what? Largest frequency, the angle. Pie chart is just what? Represented all the frequency is what? In sectors on the what? Sector. And you can easily draw the information here that is the rice takes the what? Highest frequency, and the smallest frequency is what? Proportion from the size. And this is the system of what pie chart. When you draw your own, you're just using colors to what differentiate in this case. So these are you draw your what pie chart, but you have to know how to what calculate each sector. Number one, find your total frequency. Number two, find the fraction of the what individual frequency to the what total frequency. Number three, multiply by 360 to get your what angles and get your what materials, your ruler compass and what protractor to draw your what pie chart. So we look at the third thing, which is what histogram. In histogram, the only difference between histogram and bar chart, they are both represented in bars, but in histogram, there are no gaps between them. There are no what gaps to it. And also, histogram are also used for what group data. You can say a histogram is a graphical representation of frequency distribution. Yes, another graphical representation. They are rectangular bars placed side by side, no gap between them, unlike that of bar chart. The vertical axis, as said earlier in what bar chart, represent the frequency, while the horizontal axis represent what the variables. The variables are what individual items for what for group data or for group data, which will represent what the class mark or the what lower class. It could be the boundaries. So the area of each rectangular bar of the histogram is proportional. That is this height of what of the bars depends on the what on the frequency. Proportional to what the frequency. The higher the frequency, the higher the what height. So the histogram differs from bar chart in the following: no gaps between them. Number one, and number two, the histogram can be used for group data. In drawing the histogram of group data, the center of the base of each rectangular bar corresponds to the what? To the class mark. To the what? To the class mark. You all know how to calculate your class mark. That is the difference between what upper class limit and the lower class limit divided by what 2. This also serves as the median of what class limit. So that's the class mark, which is being represented. That's what is what for group data. That will be what your variable. Let's take this example. We'll take 2 examples on that histogram. Number 1, the following is the record of students offering various subjects in a high school. Students offered various subjects in a what? High school. First subject, chemistry, 9 students. Physics, 12. Technical drawing, 4. Economics, 11. Home management, 16. And Yoruba, 6. You all see the variables, that is chemistry, physics, technical drawing. These are the variables, while the frequencies of the students offering it about 9, 12, 4, respectively. So how do you now draw your what? Bar histogram for this one. These are what for on group data. It is easy. The variables on the what on the what vertical axis, on the horizontal axis, and the frequency on the what horizontal what on the vertical axis. Variables on the horizontal axis and the what frequency on the what vertical axis. So these are how your what histogram look like. You can see these are bars represented like that of what bar chart. But each of them there are no what space. We are using color. You might not be, you can't use color in your what in your own graph. You can just only represent them by what by the size. You can see they are what of what the size also what represented here. We use individual colors for each what subject. But take note, chemistry, the first one, 9. See it here, chemistry is what 9, physics is what 12, TD is what 4, economics is what 11. Home management is the highest, it is 16, and Yoruba was 6. That's it, they are represented by bars, but there are no gaps in between them. These are your histogram would look like just has to be bigger than this compared to that of the system. But what the size of the bars has to what equal what? Width, but there is no space in between. The width are still the same, but there is no space in between them. Take another example. For what? Group data. This is for group data. The following are the masses of 50 men in a sport camp in kilogram. The following are the masses of 50 men in a sport camp in kilogram. These are their masses. That is 64, 14, and you can look at the variables here. The variable, the frequency here are 64, 14, 17, 48 for 50 men. So number one question says, prepare a frequency table with class interval. Prepare a frequency table with class interval of 10 to 19 and 20 to 29. You can see we're following with that one. That is the class width is what? 10. You all know what class width. We talked about that in the previous what? In the previous class. Class width of 10. So you're going to 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, down to the highest number, which you can see is the highest number there is 64. Probably you stop at 60 to what? 69. So number two, draw a histogram to display the data. And number three, how many men have masses above 50 kilogram? How many men have masses and above 50 kilogram? Masses above 50 kilogram. So these are your, I told you the group data, you use your class mark to represent your what? Your variables. Your what? Your variable. Class mark represents your what? Your variable. So class interval says 40, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59, 60 to 69, 70 to 79. That is, there's a range of what? 70 between the what? Yes, there's 72 there. So you stop at 70 to what? 79. We follow how we used to calculate our 10 to 19 is 6. So let's cross check. 14 lies between 2, 17 lies between, that is 2, 15 is in between 3, 10 is in between 4, 19 is in between 5, and the last one is 19, between 6. So you do that for all the intervals. So you get a what? Class mark. You get a what? Frequency. This is what? Frequency. This is frequency here. And the next one is what? The class mark. Frequency. And this third one is what? The class mark. That this class mark is gotten by what? Adding the what? Lower class limits and the what? Upper class limits divided by what? 2. That is 10 plus 19 divided by what? 2. 29 divided by 2 will give you what? 14.5. Your frequency is represented on the vertical axis, while class mark, which is what? The variable represented on the what? On the what? Horizontal axis. The only difference between this is what? Class mark in between the group data and the group data is that your variable, you have your what? Under this now, you have your variables automatically, but using what? For class mark, for group data, you use your what? Class mark to represent your what? Your variable. The frequency remains on the what? On the vertical axis. So 3 tables you use here, 3 columns you use here, class interval, which I will give you from the what? Question that is from 10 to 19, 20 to 29, you already know that your class width is what? 10. And get your what? Class mark from there. So this is the graph. This is how you now represent what? The graph. I see the class mark here, that is use color to represent the what? Individual class mark, and the frequency remains on the what? On the vertical axis. 14.5 is 6, 24.5 is 10, 34.5 is 13, 44.5 is 11, 54.5 is what? 6, 64.5 is what? 3, while 4.5 is what? 1. So that's how you represent it. So the third question says the number of men having masses above what? 50. Number of men having masses above what? 50. You have that from the frequency that is above 50. This is it. 60. From 50 above is what? 6 plus 3 plus 1, which will now give what? 10. 6 plus 3 plus 1, which will now give 10. So the last thing we'll be considering is what? Cumulative frequency, what? Curve. The cumulative frequency curve, which is the last one we'll be considering. That is, this is the curve derived from what? A cumulative frequency table. What you need to do here is what? Get your what? Cumulative frequency table. But let us take the parameter so you understand very, very well. It has been stated earlier that the sum of all the frequency from the first to a particular class is referred to as cumulative frequency class. Yes, that is the sum of all the class, represent the last number on the what? Cumulative frequency column. The graph of the cumulative frequency curve is also called OGIF. I told you earlier, we use OGIF. It's called OGIF. Cumulative frequency curve is called OGIF. Cumulative frequency curve is the plotting of the upper limit of each class boundary, the upper limit of each class boundary, and joining them together. This is not, we are not using bar or sectors here, we you're using points, so you join them together, but you are considering your variable to be what upper class limit, upper class boundaries. You're using what upper class boundary of each class to represent your what your variable. The usual procedure is to create a class before the upper class limit with 0 frequency. Before the upper class limit was what 0 frequency, the class with 0 frequency will definitely touch what horizontal axis. That is, your curve must touch the horizontal axis. How do you not get that? You represent the first line before the first class limit as what 0. Because before the class limit, first class limit is what 0. So that the what curve touches what the horizontal axis. So the cumulative frequency curve OGIF can be used to evaluate the median, quartile, percentile, decile, interquartile, and what interquartile range. But this will be looking at them in the next class, because I can't give you that in the next class carries all these information about percentile, quartile, decile. So I will teach you that in the next class. But for this, the sake of this class, we just look at the curve. But this is what the curve can use it to evaluate all this information. That's what they said, drawing inferences from what curve. When I teach you that, we will come back to it and show you how to draw inference. Look at this example. This table below shows the frequency distribution of marks scored by 800 students. Total frequency is what 800 students in the physics test. Look at the variable. Look at the interval 10 to 19, 35. This one we are not using. We don't have a collection of data that we have to break down. So they're putting it down for us in the table. Class interval of 10 to 19, down to 90 to 99, and we have all the number one question. Excuse me. Construct a cumulative frequency table. And number two, draw the OGIF. Draw the what? OGIF. Since you are going to be using the frequency, you're going to be using the upper class boundary to what? To get your what? To draw your cumulative frequency curve. So you have to what? Include your what? Class boundary in your what? Cumulative frequency table. Whereby you have what? Class interval, class boundary, and the frequency cumulative frequency. But I told you earlier from the explanation that the first class has to be represented by what? 0. So first class column is what class interval 10 to 19 down to 90 to 99. The class width is 10. And here class boundary is what? Subtracting the lower class limits by what? 0.5 and adding what? Upper class limits by what? 0.5 to get the what? Class boundary. So the less than the class what? Before the upper class, the first class is what? 9.5. So you have a frequency to what? 0 and 0. So this is how you get what? You already know how to get your cumulative frequency. Let's just go through it again. That is 0, 0, 35 is the first frequency. The first frequency also gets what? 35. So 85 is the next frequency. You add 35 plus 85 to get your what? Next class interval. 120 plus 150 to get 270. 270 plus 130 to get 400. Down to what? 740 to what? 60 to get what? 800. I said earlier in the question, 800 what students is the what total frequency. So how do you represent what? The graph. Your what? Upper class boundary will be on the what? Horizontal axis, while your what? Cumulative frequency represent what upper as the vertical axis. This is a graph. I told you OGIF is a graph derived from what a what cumulative frequency table. So your frequency on this one will be what the cumulative frequency, which will be what on the vertical axis. While the what upper class boundary, starting from the lesser, which is what 9.5, which is the lower class boundary, start from there so that your curve can touch the what horizontal axis down to the what at 99.5. So this is what the graph will look like when you draw it. You can see the cumulative frequency is represented on the what on the vertical axis, and the what horizontal represents what and the very that what upper class boundary. You know our upper class boundary starts from what 19.5, but you have to start from what the lower class boundary first class, which is what 9.5, and the frequency is what at 0 to touch the what horizontal axis. And each what is represented like this. So this is the curve of a what of cumulative frequency curve or OGIF. So I would like you to practice it. Represent you point state point of what each cumulative frequency of each cumulative frequency to the what upper class boundary to get your what point, and these are the points. Then you join them together to get your what your curve. So this is the statistical graph for this topic. We've come to the end of the class. I believe you now understand how to what represent your data in what in the bar chart, in the pie chart, in the histogram. You know there's a difference between histogram and the what and the bar chart. That is, there's no gap in what histogram. While in the cumulative frequency curve, you use your what cumulative frequency table to present each other. Attach something that there's an assignment on the online. I believe with this explanation and with the notes, you'll be able to solve them. And don't stop there. Go to your textbook and solve further questions. Draw as much graph you can draw, and you can draw when you know on the question. You'll be able to just draw all the what graph explained in this topic. Thank you very, very much, and have a nice day.